Hey everybody, thanks for joining me again today. Sorry that it has been so long since my last post. I have a day job. So wanted to jump right in, pick up where we left off last time on our I Can Build It Myself IoT project. I've got a bunch of stuff to go through today. I wanted to cover a couple things that I missed in my last video, just so that everybody's caught up. A couple of things about the Raspberry Pi that you should know. Our original project, we're aiming to use one of these. This is a moisture sensor, right? And it detects the resistance of transmitting a current from point A to point B between those two prongs of the sensor, and by doing so, it tells you how much water's in the soil, right? So that's the original purpose of our project. The problem with that is that this is an analog mode sensor, and the Raspberry Pi, the way that it comes, in the box, is digital only. So that means on and off in this case. So I can set a threshold, and it will alert me when the water level drops below that, i.e., the resistance across these 2 points gets so high that it no longer receives a signal. But that's not really what I want. I'm looking for optimal water conditions, and so I need to be able to track the water level over a long period of time, and then I want to compare it to observed, performance of the plant and things like that. So I need to be able to actually record the resistance and then find the resistance that equals the right level of water. To do that, I needed to order a special chip. I'm not going to talk about it a ton in this video, but I wanted to call that out, that the Raspberry Pi is digital only, and what that means is off and on, really good for triggering thresholds. I have another project that we'll talk about in a future video that's a sound detector that's perfect for that type of thing. If a sound goes above a level, it will trigger an event. And that's obviously a very common IoT thing. If something goes above or below something, I want to trigger an event. So it's great for those kind of things for event triggering. It's not good for recording like a long time series of events. So important to know when you're thinking about your own IoT projects. That's something that you can work around. We're going to talk about how to integrate this ADIC chip that modulates the digital inputs and actually kind of helps you figure out an analog frequency. So we'll get to all that. The second one that I ran into right away as I was starting to build projects. So I ordered from CanaKit on Amazon. I've been very, very pleased with all the stuff that I got. But you can never get enough of these, the little wires, the breakout wires, and you can never have enough of these project boards. So I went back and ordered a bunch more. I highly recommend when you order your Raspberry Pi kit, if you plan to do so, order a few extra of these. I think the kit with like 5 of these little guys in it was $6, and I think the big one was 10. You're gonna burn down wires, plugging stuff in. It's really nice, and we'll see it when we assemble this here in a second. It's really nice to be able to do color coding. Black is out, red is in, that kind of stuff. And you just won't get enough wires in the original kit, and you won't have enough of these project boards to sort of do all the breakouts you want to. So just so order those. The only other things that I didn't talk about in the initial setup video that we did last time, I didn't show assembling the breakout board assembly. It's really easy. You just plug it in at the top of one of these breakout boards exactly like this looks, and plug the ribbon cable in from your Raspberry Pi. It takes all of about 2 seconds. And then there's some other things that you should do on your Raspberry Pi. First and foremost, get it set up for SSH. It makes life so much easier when you don't have to find a monitor and use your keyboard and mouse. You'll need it for the initial setup. Once you get the wireless configured and you do the Raspberry Pi updates and all that stuff, then using SSH is invaluable, and now I can just terminal in from my laptop. I don't have to worry about having the Raspberry Pi, right next to the TV or next to my computer monitor. I can put it anywhere. Obviously, kind of useful for IoT. And then the other thing is some other stuff that I did. I put GitHub on it. It's just a sudo apt install git. Takes about 3 seconds to do, and that way I can share my code on Git, but then I can always pull the latest versions if I make changes, and that allows me to actually do my coding instead of in Emacs or Vi or something like that on the Pi itself. Obviously, I have nicer tools on my Mac that I can use. So those are just a couple of recommendations. But what we're going to look at today is our LED, Hello World project. So we're going to blink LEDs, and I'm going to show you how we, the parts we use and what we configure and how we wire it up. And we'll build one out, and then we'll look at the code, and I'll show you all of that. And you should be able to do it all yourself. It's a very straightforward project, but it illustrates some of our key concepts for using the Raspberry Pi and the sensor packs with IoT projects. So without further ado, let's take a look at how we do that. All right, so I have one already assembled on the micro breakout board. You could, of course, do it on one of the larger ones, but it's very small. It only needs a few pins, and so I just did it on a small one for portability. You're going to use 4 things. Obviously, an LED. I chose blue because that's my favorite color. You'll notice when you look at the LEDs, and I'll try and hold this up to the camera so you can see it, one leg is just slightly longer than the other of the pins for the LED here. The long leg is the power inside, right? And the short leg is the out. So when you're wiring it up, that's the only really important part you have to remember. I have wired it backwards and it works, but I have read, and I'm sure it's true, that you'll burn the LED out if you do it that way for too long. So definitely make sure that you pay attention to that. So that's the LED. Obviously we need 2 wires, power in, power out. I'm using red for in and black for out. And then you need a resistor. The reason for the resistor is that when you run an LED, it's on and off, and it can fry the LED if you run it at full power because it's not designed to hold that power for that long. So we need a resistor after the LED to burn off some of that extra power so that it does not fry the LED and could potentially damage the Raspberry Pi GPIO stuff. So definitely don't want to do that. So all of that said, those are the 4 parts you need. This resistor is a 330 ohm, and I know that because it was labeled in the CAN kit. You can get guides that will tell you how to read the color coding. For you electrical engineers, you will know that natively, and I am jealous of you. For everybody else who is human, we can get a color code that will help you read these, but honestly, if you buy the resistor kit that's online that comes with all the extra wires, then it's labeled, which is really nice. So let's look at how we order this up. So on these breakout boards, in order to understand how they lay out, things going this way do not connect to one another except for the outer power rails, right? So that's true on the big breakout boards as well. Things going this way are connected together. So if I put something into column 3 here, or column 5 here, and then I put another pin into column 5, those things are connected together. They are split down the middle, so it's only this side that talks to itself. And so I can wire these 2 projects together on the same board because they're not really together. So I'm going to have power come in, and sometimes these are a little finicky, but you'll get it eventually. Power's going to come in, it's going to go to my LED, so I make sure that goes in the right spot, and then it's going to come out of the LED, and it's going to go into a resistor, and you can just bend the wire on the resistor and plug it in if you're not completely incompetent. Like I said, it's not always the easiest thing in the world to get these in sometimes, and that's why these breakout boards are invaluable, because you don't have to solder, you don't have to do anything special, you just have to make the wire go in the hole. And then that other end of that resistor is going to go basically wherever I want it to. In this case, I've dropped it into 21, could have just as been easily 22 or 3 or 5 or whatever. And then I'm going to have power come out, and that'll go back to one of the ground ports on the breakout board on the Raspberry Pi. So now to connect this to the Raspberry Pi, I have used specific ports, and you will see them in the code, but we're going to connect them up to the correct ports. Power out comes from one of the numbered pins on the breakout board here. In my case, I have used these specific ports, so I'm going to plug into them for power out. And coming back from that, I go to a ground port. Now, I haven't fooled around with this, but I suspect I could probably go back to the same ground port with both of these, but I'm not going to. I'm going to go to separate ground ports. And again, the ground is just a loop, so it doesn't really matter which ground is labeled GND on the breakout board. That's all you need to do. So now that I have connected this to the Pi, I can execute my code on the Pi, and we'll look at the commands here in a second. I'll overlay them. And I will blink my light. Congratulations, you have blinked a light. That is hello world. We're going to look at the code, of course, but that's how hello world works. I actually have a second one that allows me to blink both of them, just so that you can see that we are actually wired up correctly. Why is this so important? Why is the hello world project so interesting? I have learned how to turn ports on and off. That is the functional mechanism for reading and writing to sensors. I need to be able to do that for my IoT projects, so I have learned how to manipulate the GPIO ports within the Raspberry Pi to send and receive signals. That is exactly what the Raspberry Pi is designed to do. Okay, so let's take a look now at the code that actually does the blinking of the LEDs. So I've got my LED block, everything's wired up, Raspberry Pi is connected, I've connected via SSH. So if I go into my terminal window here and I list, I'm in my Pi projects directory. Remember, I'm pulling that down from GitHub. That is as simple as sudo git pull, and it's already up to date because I've already done it before we started the recording here, obviously, to make sure everything was ready. But let's take a look at the led.py script, which is our hello world script. I'm just going to cat it for easiness here. This is the LED script. You can see it's not complex. It's very simple to write. I honestly went out and Googled how to do this and read about it. I understand the code. I know how to write the loops myself and all of that. But this is it. I have documented this so that when you go out to GitHub and you want to use it, the links will be provided. You can go ahead and make this your own, do whatever you want to do to change it. But let's talk about the important parts of this code here. So, really important one, the very first one, RPi GPIO. That is the library that controls the GPIO pins that the Raspberry Pi can initiate and receive signals from. Having this as a library within our code obviously just makes it so we don't have to write lines and lines worth of code every time we want to turn a pin on or off. Time is just what we're using for the intervals and things like that, so that we can do sleep and things like that. So our blinks aren't so rapid we can't percept them with the human eye. The next thing we need to do is we need to define which pin, and that's labeled on the GPIO breakout board, but that's which pin are we going to turn on and off to blink our LED. How often are we going to do it? How long are we going to wait in between? That's our iteration and interval values, and those are just value names. You could call them whatever you wanted to. These are the key commands for GPIO, right? So the library that we've imported higher up here. We're setting the mode to BCM, which is the interactive mode, allowing the application to communicate with the GPIO pins. Set warnings to false is not a recommended setting for production-ready code. Would highly recommend not using this in your final projects. What this does is if there's anything wrong with the GPIO board, it basically will keep the code running. If you're first screwing around with it and you forget a question mark or a colon or closed parentheses, it's useful for that so that your code doesn't blow up all the time. But reality is you should not do this in your production ones. In Hello World, totally fine, not an issue. And then the last one is we're actually going to set our pin that we defined up here to be an output pin. There are two GPIO modes, output and input. Remember, the Raspberry Pi is digital. It is on or off, in or out. So the input mode would be if I'm receiving a signal from a sensor, and we'll see that in later projects. The output mode allows current to flow out of that pin and to whatever, in our case, our LED. So all we're going to do is just do a loop. So I want, the iterations that I have said. I want 10 iterations for x in the range of 1 to iterations plus 1. Do this. I'm, writing this out to the buffer, and I am turning on and off. That's GPIO high, GPIO low, the pin that controls the current flow, which allows the LED to turn on and off. High and low, I don't know why they didn't do on and off. That's fine. High is on, low is off, and that just allows the current to flow through it. And then at the end, I found this in my readings. Highly recommend you put this at the end of every one of your programs, because if something fails, a lot of times that GPIO port can be left turned on. That could cause problems with your sensors or burn out your LEDs or even damage the Raspberry Pi. Doing a GPIO cleanup just basically turns everything off and resets it back to null state. So running this is really easy. Just sudo python led.py, and you can see it's going to loop through my loops, and what you can't see because you're looking at the screen is in the background my LED is blinking on and off, just like we showed you earlier in the video. I also have the LED 2, so if we do LED 2, this is the one that turns on and off both LEDs, and you can see it's just a double. Basically all I did was add a second pin, right, pin B, that goes into output mode, and then I do GPIO high commands twice and GPIO low commands twice, and then the GPIO cleanup. It's effectively like I could blink as many LEDs as I wanted to in this way, right? And I've seen some uses of this for meters, right, where it's yellow LEDs and then a red one at the top and that kind of thing. There's some very cool things you can do with this. And this might seem sort of trivial, and it is trivial in the sense that it's very easy to do, but that's the point of Hello World. And B, this is critically important because we've learned the first step to interacting with things with our Raspberry Pi. The GPIO high and low command allows us to turn things on and off, and we're going to use them a lot as we go through our other projects. So really, don't get bogged down in the fact that this is super simple. It's the key foundation step for us doing all the next things that we want to do. And so if just to run this so that you guys can see what it looks like, so you'll know what to expect when you do it yourself. If I do LED 2 pi, you'll see the same thing: loop 1, loop 2, LEDs on, LEDs off, LEDs on, LEDs off. You can modify the code as much as you want to remove the cascade effect, right? So it turns one on and then the other, and then one off and then the other. You could blink them both at the same time, whatever you want to do. The code's yours. Go out to GitHub and download it and do with as you please. Happy to share it with everybody. And we'll continue to post all of the code up there for you guys as we go forward. Okay, so there you have it. Raspberry Pi Hello World project done. We have successfully blinked LED lights with our Raspberry Pi. And I hope that this has been instructional and informative for you. Again, the code available on the GitHub link you can see on the screen right now. And if you have any questions, feel free to drop me a line, comments, requests, anything you guys want to know about. I'm happy to try and include future projects. Like I said, our next project, we're going to wire this guy up. We'll talk about how we transform the digital-only Pi into an analog-capable device. I have an Arduino board, which is natively analog. Depending on what project you're doing, it might make more sense to use the Arduino. Might make more sense to use the Arduino in concert with the Raspberry Pi. That's definitely something we'll look at down the road. But tune in next time when we look at how to wire up our actual sensor. And then another side project that I've been working on, we've got our sound sensor, so I'll show you how to set that all up as well. And again, hope you enjoyed it, hope it was useful, and look forward to seeing you next time on another exciting build-it-yourself IoT video.